This question, we are told, is about a metal bar being driven into the ground. It can be driven into the ground using a heavy falling object. So we have a heavy falling object that we are told here is 2,000 kilograms, and again down here is 2,000 kilograms. And it hits this bar of a mass 400 kilograms. Strikes the bar at a speed of 6 meters per second, so the V is 6 meters per second. Comes to rest on the bar without bouncing, so that means that eliminates the possibility that it's being hit multiple times. The bar is driven into the ground to a depth of 0.75 meters, so if we just take the center of mass of this bar and we do an after drawing, well, it's now down 0.75 meters, however much that is relative to the bar. So we have a change in height of 0.75 meters. And of course, that big mass is sitting on top of it. That entire time. And when it comes to a rest, we have this kinetic energy when the bar hits it, and it comes to a stop at the bottom. And it's got momentum and a certain velocity. So we're told that's what happens. Determine the speed of the bar immediately after the object strikes it. So we want to remember this big structure we have built in this course, that we have mechanics, and we have what happens, and our kinematics, and we have our dynamics about why things happen the way they do, and there are two ideas that govern everything in the universe, and that's the law of conservation of momentum and the law of conservation of energy. So when we apply ideas to this situation, it should be absolutely true and reliable. We should be able to verify every aspect of it with momentum and energy. So what we have going on here is a collision, and we know that collisions are about momentum. So we have the momentum before must be equal to the momentum after. And beforehand, the momentum must be due to the block, or the object, P0. We'll call it the POB for object. And then after, these two move together as if they are joined. So in that sense, it's an inelastic collision. It's an inelastic collision. We have one particle becomes two, sticky collision. So we have the momentum of the two together, of the combined, and this is MO, VO, and afterward we have MO plus MB, the two masses, times its new velocity. And we want that speed, which is V prime, so V prime is M0 V0 all over M0 plus MB. So that looks to be 2,000 times 6 all over 2,000 plus 400, or 2,400. Now we have the wonderful, great fortune of having numbers that are going to work together very nicely. So we can get rid of these powers of 10. We can see that 6 into 24 is 4 times. And so we're left with 20 over 4, which is 5.0 meters per second. We stop and ask ourselves, does 5 meters per second make sense? Well, we do expect that velocity to be less than 6, and it is. So that's the velocity at the moment after it strikes. Now we are asked to determine the average frictional force exerted by the ground on the bar. Well, the frictional force. Let's see, the bar, as you pound it in the ground, the metal interacts with and comes into contact with increasing amounts of dirt material. So we might expect that the force of friction should increase over time. That's why we're being asked to find the average frictional force.